Yeah, hello everyone. Am I audible? Satya here.
Good evening, all the participants. I am Anup Tiwari, co-coordinator of Faculty Development Program on recent trends on 5G and 6G wireless networks. Today is the third day of our session of our FDP. First session will be held by Mr. Dr. Satyakumar Venkayala, who is working in Samsung Research and Development Institute. We are just waiting for some more participants to participate now. We will wait for just 5 minutes, then we will start the session.
Hello, madam. So you can share the slides, right? Someone can share the slides? Vani, madam, can you share the slides?
Sir, just 1 minute. I will talk to him. Sir, you have no slides with you.
So, I mean, see, basically, I can't use my office laptop for this meeting. Basically, you are using Google, right? Google
Okay,
Meet.
okay.
So I can't use that software in my office machine. So I'm using my mobile to present.
Okay, sir, just give me 5 minutes, we'll talk. So, dear participants, today our first speaker for today is Dr. Satyakumar Venkayala, who is in Samsung R&D Institute, Bangalore. He has completed PhD from IISc and Masters from IIT Guwahati, Bachelor's from Geetam University. About his experience, he is working as an architect and chief engineer in Samsung R&D from past 7 years, and he has worked as research assistant in IISc. He has also worked as radio resource management expert for 2 years. About him, he has developed user equipment centric throughput optimal algorithm for 5G multi-connectivity system. He has developed optimal and suboptimal HARQ pooling algorithm for 5G multi-connectivity system. He has developed centralized, distributed, and hybrid algorithm for dynamic and flexible TDD-based 5G RAN. He has developed centralized and distributed algorithm for in-band full duplex communications for 5G system. He has developed uh, algorithm for optimal routing and power allocation for D2D communication. He has developed optimal and energy efficient algorithm for various quantity of service such as average delay, minimum rate guarantee, stability, hard deadline constraint for wired and wireless radio systems. He has developed optimal and computationally efficient algorithm for multi-hop wireless system for different end-to-end and quality of service. He has more than 25 patents and 18 publications. So we'll like to invite our sir, Dr. Satyakumar Venkayala, to please start the session. We are just uploading his slides. Just in 2 minutes, we will be starting our program.
Yeah, thanks, Professor, for invitation. Yeah, so yeah, briefly, I did my PhD from IISc in the Mac layer scheduler. In Nokia R&D, I have worked on Mac related activities. Mac layer and means scheduler. In Samsung, I worked in a physical layer and RRC, RLC, PDCP, and so on. Yeah, so published close to 45 to 50 papers, 45 to 50 patents so far. Yeah, in different layers altogether. Especially most of the patents are from Samsung. So just want to know your background. So most of the faculty are from ECE or electrical are also there.
Most of the faculties are from ECE, but from several other branches also, some faculties are there, sir.
Okay,
Hmm. But
okay,
maximum are from ECE.
okay. So what about your college? What is the background of your college?
Sir, we are from Samskruti College of Engineering and Technology. It was established in 2005. It is a part of Samskruti group of institution approved by AICTE, JNTU, Hyderabad. Now it has NAC affiliation, NBA affiliation. We have basically branches like ECE, CSE, CSD, and CSM, mechanical, civil. These branches are there. Also, MBA is there, and for other in our Sanskruti group of institution, uh, this diploma polytechnic college is also there. Pharmacy is there, and several other courses are also there. Our website is www.samskruti.ac.in. So in that we can see every details about at Samskruti College of Engineering and Technology. It is one of the most reputed college in this area.
Okay.
Mm.
What all branches are there?
Branches are CSC branch is there, CSM machine learning, CSD data structure, EC is there, mechanical, civil, triple E. So these all
Mm,
branches are there, sir.
okay. Nice.
Mm. Almost 2000 plus students are there in just engineering college, and pharmacy all different other all students are there. In polytechnic also 2000 or 3000 students are there. So total in
Okay.
campus, this Samskruti group, you can say ki 7 to 8,000 students are there, plus more than 200 faculties like an engineering, diploma, pharmacy, 200 to 250 faculties are there. So
Okay.
this is all about. Sir, I think your presentation has been uploaded. So I request you to just please start mm, your
Okay.
presentation seminar. Thank you, sir.
Sure, sure. So call me Satya. Sorry is not needed.
Oh, sir.
Okay. So
Mm.
feel free to ask me any questions. Doesn't matter whether it is small or a tough question. Okay.
Okay, sir.
Okay. So right now today I will be giving a presentation on resource allocation in heterogeneous networks and CQ estimation, how it is done. Okay. So I will try to explain it in a very simple way so that you'll get to know what we are doing in industry and so on. Yeah. But in case if you find it little hard, do let me know. I will try to avoid the jargon and try to explain in a simple language. Yeah. Let's go to next slide. So today I will be covering basic architecture of telecom systems and MAC scheduler. MAC scheduler is the one which allocates the frequency resources to each mobile user. And there are different types of schedulers, and I will be covering some of them, not all. And then single rat hetnet and multi rat hetnet. So RAT means radio access technology. So 2G, 3G, 4G, 5G, you can call it as 2G RAT, 3G RAT, 4G RAT. So hetnet means heterogeneous networks. And I will also try to explain what are the advantages of single and multi RAT and their disadvantages. And then how CQI estimation is going to play a role in the scheduler. And then how we are using machine learning for estimating the CQI. Also, I will try to explain what are the legacy methods, how we estimate the CQI and so on. CQI means channel quality indicator. So channel quality indicator, it itself like signifies something which you might have already guessed it. So user equipment means mobile device, laptops, and so on. They estimate the channel quality and then report it to the base station, and base station uses the information and then it will allocate the resources. Okay, at high level. Okay, this is the agenda for today. So shall we start now? I think most of the faculty have joined, I guess. So shall we go to next slide?
Yes, sir. Yes, sir.
So this is a telecom architecture overview. So this kind of stack is there at the UV side, similar stack at UV side and base station side. So physical layer and MAC layer, RLC, PDCP, IP, application layer, and so on. Okay, so today I will be covering MAC layer. Mostly my focus is on MAC layer and little on physical layer. So this topic is quite useful for CS faculty as well as EC faculty. Yeah, so let's go to next slide. So as I mentioned, this MAC layer is the one which plays crucial role. Why it is so crucial? So there will be n number of users under each base station, and each base station will also experience interference from the neighboring UVs also, neighboring base stations and so on. Uh, so these UVs will have different channel conditions. The user who are near to the base station, they will have better channel quality, right? And users who are away from the base station, they might have poor channel condition, right? But at the end of the day, operator will check. Uh, Operator would like to satisfy every user, but there are some constraints. A poor guy, poor user means poor channel condition user need more resources to get the better QoS. It is like this. For example, in your classroom, there will be some smart kids and some average kids and some dumb kids. So as you mix all of these people, okay, it is quite challenging to make every student happy. For example, if you teach very fast, intelligent people will grasp all your concepts. Mediocre students might find it little difficult, and dumb students might find it very hard. Right? If you go too slow while teaching, and intelligent student feel boring, and probably mediocre student also might feel boring, little boring, and a dumb student might be very happy. So at the end of the day, you may not make everyone happy. Yeah, you can make happy if you classify all the class students into three groups, let us say smart, mediocre, and dumb, right? In the same way, right now, you cannot pump data, too much of the data on a given user if the user channel condition is bad, right? You might have already observed that if the channel condition of user is bad, then your throughput also will be less, right? Right? So throughput means data throughput. Okay. In case if you have any questions, feel free to ask me anytime. Okay. So now operator generally will be little bit fair to every user. For example, if operator allocates all the frequency resources to the users who are actually having good channel conditions. Okay. So then what happens is that if the channel condition is too good, the throughput will be very high. If throughput is more, then operator will generate a lot of revenue, right? So operators generally sell the plans based on the data throughput, right? So, but there is a problem here. If operator is greedy and allocate the resources simply based on the greedy algorithms, such as allocating the resources directly proportional to that of channel condition. Okay? Shall we wait for another 5 minutes or is it okay?
Okay, sir, you can go ahead, sir.
Yeah, okay. Yeah, I don't want other people to miss the lecture. Okay, so operator, see at the end of the day, for we all will pay the money to operator. Whether you are near to the base station or away from the base station, the charges are same at least for now, right? They are directly proportional to the throughput. So what they came up with this fairness algorithm, I'll explain. So they will try to give some weightage to the channel quality between the base station and user, and some weightage to the throughput served. Throughput served means how much throughput he consumed in the last couple of milliseconds. That will be placed in the denominator. So for example, if there are two users and if one user is actually getting good data rates, let us say, and if he is competing with the second user, operator generally what he does is he will try to slow down throughput of the first user. Why he will do? If you allocate all the resources to this person, what about the other person? Other user will starve, right? Right? So operators have come up with a couple of algorithms which I will explain it to you down the line. And You might have also heard of fairness, which I will try to explain at high level. And next thing is, have you heard of quality of service? I'm not sure if you have not heard of it. So there are multiple applications in the 4G and 5G and so on. Right now, we are using in India for 2G and 4G and 5G. Okay. So in the two, so you might have observed that there are multiple applications. For example, voice call over the network, voice call over the app, video call over the network, video call over the net app. App means WhatsApp and other mobile applications. Okay, and web browsing, which is called elastic data. Okay, so there are two types of QoSs at broad level, elastic and non-elastic, or GBR, non-GBR. You can name it whatever you want. I mean, basically, elastic means it allows you, extra time to transmit. As simple as that. So, yeah. So there are multiple applications. For example, online video gaming. And retransmissions. Retransmissions means when the transmitter transmits to receiver. Transmitter can be a base station or user equipment. User equipment means mobile. Okay. When transmitter transmits a packet to receiver, receiver should acknowledge saying that it received successfully. Okay. In case if it is successful, we will transmit next packet. In case if it is not successful, so we will retransmit it. Transmitter will retransmit. So we have three retransmissions. Okay, in the 2G, 4G, 5G so far, but there is a IoT devices. You might have heard of it, Internet of Things, right? So am I going slow? If I'm going slow, let me know. I will go a little fast. If I'm going fast, let me know if I will go a little slow. Okay. Yeah. So in the IoT devices, you can retransmit 256 times, 512 times, and 1024 times, and so on, in the order of 2 power n, where n is greater than 5, 4, and so on. It depends on 4G IoT or 5G IoT device. So there are multiple QoSs, and we have to take care of all these QoSs while scheduling, while allocating the resources. Okay. So, and there is a load balancing thing which you might have heard of it, when there is a heavy load on the network, how it manages and so on. Okay, and what techniques we we actually use to handle these scenarios, and also we means a base station should also take care of uh, dynamic load. Okay, let's go to next slide. Yeah. So as I mentioned that, so scheduler purpose is there are a couple of resources, frequency resources, and these frequency resources should be distributed to the users dynamically. So there is no concept of called static resource allocation. For example, if you have some 100 resource blocks, frequency resource blocks, and in that base station, there might be like some 300 to 400 users. How it will handle? In case if you allocate resources in a static manner, it is very hard to serve all 400 users, right? So what it does is, base station will allocate resources dynamically in every time slot. Let us say 20 users will be served. So duration of time slot in 4G system is 1 millisecond. In 5G system, it is 1 and zero point 0.5 millisecond and 0.25 millisecond and so on. Okay. So, so how we allocate the resources, I will try to explain at high level. It's quite hard to explain in 1.5 hours, but I will try to do my best so that you will get some idea. So base station will transmit a reference signals. See, reference signal, what I mean by reference signal is that, so it will transmit with certain power, and UV also knows what is the transmit power, and UV receives some power. Let us say base station transmit P, and UV receives P minus delta, so it receives less power, right? And it computes what is the channel quality based on P and P minus delta, and it reports that okay, this is my channel condition. If a user is near to the base station, loss will be very less. If you are away from the base station, loss will be more, right? So, and it will calculate channel quality. There are some formulas for CQI which I will also explain down the line, and it will report back. User equipment will report back saying that this is the channel quality. Based on that, it will allocate the resources. Okay. Uh, so there are multiple parameters while allocating the resources. So base station will see the channel quality of the user and data requirement. For example, if you are browsing YouTube video, so your data requirement will go high. If it is a voice call, data requirement is very less. If you are browsing content in the web browser, based on that, there will be a data requirement. So based on that, it will allocate resources in a fair way, in a way that other users will not get impacted. It will do its best. Of course, if there is a sudden inflow of 1,000 or 2,000 users in a given base station, you might have observed that though you have a good signals, but you will not be able to send or receive the messages. For example, if you go to cricket stadium where around 20,000 candidates might come, so in that scenario, base station will be heavily loaded. So in that case, base station will be little helpless. So operators generally what they do is they will allocate more resources to the postpaid users, and second priority will be the prepaid users. Okay. Yeah. So so there are two types of schedulers. To send the reference signals, base station will use round robin scheduler. You might have heard of round robin scheduler, right? So it will allocate resources turn by turn. Okay. So it's like in the computer systems you might have heard or studied a round robin scheduler, where if there are n number of tasks, let us say computer CPU will allocate resources to one task at a time, and next time it will allocate resources to second task, third task, and so on, right? And similarly, in the round robin scheduler, what it does is it will allocate equal number of resources to all the users. So these resources are used by the UV, and it will compute the channel conditions and report it back to base station along with the QLens. QLens means data QLens.
Sir,
And
yes,
what
sir.
type of,
Sorry for the
yes,
interruption. Please switch on your camera, sir.
no, madam, okay. Okay, I will switch on after a few minutes. I have to get out of my building to switch on, so they put some stickers on our cameras. Okay, I will turn it on after a few minutes. Huh?
Okay, okay.
Yeah. So if I go out of the office, they will actually track my timings,
Oh,
right? So if I'm out of office, they will get on. Okay, I will do that. Okay. So next thing is, so yeah, this is how channel conditions are actually collected by the base station, and base station will also allocate resources for shared channel. Shared channel means once reference signals are transmitted to UV, UV will calculate all the channel conditions and reports it back to the base station, as I mentioned, along with the QoS type and QLens and channel quality. And base station will have some metric. Okay, just like the way you people evaluate the students based on the practical marks and mid exams and what do you say? Uh, so final exams, lab exams, whatever. So each professor will give different weightages. Okay. So everyone has their own opinion, right? For example, some subjects you might have to give more weightage to the practicals, and theory may be little less significant there. In some subjects, theory is more important. You will come up with more weightage for those subjects, right? Similarly, base station has certain metric, right? Metric means there is a formula, and that based on that formula, it will give ranking. Okay, so if there are some 200 users in the system, it will rank all the 200 users, and it will pick top 20 players, I mean top 20 users, and base station will actually allocate the resources one by one on high priority basis. Okay, there are like different applications as I mentioned. So each application has, for example, like some people have missed it while explaining, voice call over the network, and that is quite different that of the app voice call, and video call over the network is quite different that of app video call, and web browsing and online gaming and so on, right? So again, these applications have certain ranking system, okay, and retransmissions also are also there. So based on these factors, it will rank, okay. Also, one more constraint is there in the denominator. These are all parameters. If the quality of service QoS rank is higher, your numerator term will go up. If the Q length is more, your numerator term will be directly proportional to that of uh, uh, the metric. Okay. So far it is clear, or should I explain a little more? Please let me know. Are you following? Hello? Yeah. So yeah, please let me know. Yeah. Yeah. So thing is, so base station will shortlist 20 users out of 200, and it will again allocate the resources in such a way that it will give high priority to the higher applications which badly need resources. So usually each application has hard deadline delay. Hard deadline means when a packet is generated, that packet should be served within couple of milliseconds. Okay, if it is served after a couple of milliseconds, there is no point. For example, when we are making a phone calls, if there is a too much delay, if you receive that packet delay after a couple of milliseconds, there is no point, right? Yeah. Mohandas, I will change. I'm trying to, kind of trying to educate the basics. Yeah. Okay. So basically, all these factors are considered while allocating the resources. Okay. Let's go to next slide. So this round robin scheduler, you must have heard of it, and it is very simple scheduler. If there are 200 users, it will simply pick first 20 users, irrespective of the channel condition. It will give the resources in the next slot. It will allocate next 20 for next 20 users and so on. So it need 10 slots to serve all 200 users. All right. It is very simple to program wise as well as resource allocation wise. It doesn't care what are the channel conditions of the user. Okay, so it's a simple, one cluster of users will get resources, and later on another cluster, and so on. And again, these cluster sizes may be quite, I mean, keep changing. For example, users, if they stop using any internet service or phone calls, then the requirements will come down, and then the user equipment will go into idle mode. Okay, and so it wakes up whenever there is a requirement. Okay, yeah, let's go to next slide. Usually round robin scheduler is for control channel. Control channel means you transmit channel quality, or a base station might ask couple of measurements. Okay, measurements can be there are n number of measurements. Interference measurement is there, channel quality measurement is there, and so on. Okay. Yeah, so coming to the proportional fairness scheduler. So this is a scheduler which allocates the real resources. So before allocating the real resources, you need to know the channel conditions. Okay, so that is called share. This is called shared channel. That is called control channel. Okay, control channel means we only care about channel qualities, and shared channel means we will allocate the resources. Okay, frequency resources. Okay. So, this scheduler will be fair to almost all users. So one thing is that if user who is near to the base station, let us say he gets 2 Mbps, and user who is away from the base station might get zero point 0.5 Mbps. But the speed of 2 Mbps will be consistent. Let us say there is some consistency, and even the user who is away from the base station will also have the same consistency or similar consistency. But the rates are different because the channel quality is different. Operators generally will allocate in such a way that no user will be starved. Okay, there might be some scenarios where users will be starved. We will be operator will be kind of helpless. Okay. Yeah, so in the fairness scheduler, it will allocate resources, and the metric is proportional to the channel quality, proportional to the queue length, proportional to the data type. Is it high priority data or low priority data? And priorities are defined in the 3GPP specifications, where each application has some hard deadline. It should be served within certain time, and also each application will tolerate certain number of packet losses. Okay, so and that is called QoS ranking, you can say in simple language. So metric is proportional to the QoS ranking and inversely proportional to the data served so far. Data served so far means we should not allocate resources to this particular UV just because channel conditions are too good. Okay, so if you served couple of Mbps, then their denominator will keep on increasing. If the denominator increases, the metric value will come down, right? So it's a simple ratio anyway. If the denominator increases, the rank will come down and so on. So that this is used for shared channel. Okay, yeah. So yeah, let's go to next slide. So for any doubts, feel free to ask me. I mean, so I don't know the background of the faculty, how many people have worked on this area and so on. It is very hard to explain and make you feel good about this presentation. It's quite challenging, right? Yeah. So okay, anyway, I'm assuming that you people are comfortable now. So right now you might have heard of machine learning. Have you heard? Do you teach any machine learning courses in your BTech? So, so I'm just asking to faculty, do you teach machine learning, Python, any AI related courses? Okay, okay, good. So right now, yeah, okay. So basically right now so far in the 4G systems, we were actually, following a certain metric, simple formula, right? So if I ask you people, so there are some 60, 70 people in this group. If I ask you what is a metric or goal of your life, then everyone has more, may have different answers altogether. Okay, no problem. So I will try to explain it at high level, right? Everyone has their own metric. What makes you happy, what you really want in your life. If I ask you 70 people, all 70 people might end up, writing different answers, right? In the same way, if there are three parameters, let us say A, B, C. Okay, let us say A is for mid exams and B is for final exams and C is for, let us say, lab exams. So if I ask you, if I give you freedom to come up with some different weights based on the course and based on your opinion. So technically A plus B plus C is equal to 100, right? Right? So this 100, some professor may give weightage 30, 45, and 25 and so on. Some professors may give 25, 25, 50 and so on. So the values which A, B, C can take is like, infinite, right? Uncountable, right? So similarly, there are some 4, 5 parameters, important parameters for the scheduler in the 5G systems. Okay, that is channel quality, queue length, and data type, QoS type, and what and the data served so far. So you can say that channel quality whole square, for example, and QoS whole cube, and Q length whole power 2, denominator whatever throughput served so far, whole square or whole cube, whatever. So you can come up with infinite number of formulas, isn't it? Right? So if there are four parameters, you can come up with whole square, whole cube, 2.5, 1.5, and so on, right? So similarly, I mean each operator will have different formulas, but the parameters more or less same. Okay, so what happens is that no one knows which scheduler is good, right? So for example, in your class, some professor X will judge one student as brilliant, and a different professor may judge a same student for a different course. He may judge that he is an average student. Some other professor may say that he is a dumb student in his course. So in the same way, every operator will do some simulations, and if I mean to find the optimal scheduler itself, scheduler formula, there are some formulas, simple formulas, which are not really difficult. They realized that there are infinite number of formulas, and they don't know what is optimal. So now people started machine learning. So I have worked with VAT Vellore on this ML scheduler part, and we have observed that close to 40% extra throughput when compared to the proportional fairness scheduler. So, so, so you may say that why it is giving extra throughput when compared to the traditional legacy proportional fairness scheduler. So in the machine learning, most of your faculty might not be knowing, but this is very much important topic right now. For next couple of years, it is quite important. So machine learning, so what it does is that it will explore new formulas, new. I mean, there is an exploratory phase where you can explore for a couple of days with the different formulas, and it will try to come up with a better metric. Okay, and if the metric is good, your throughput will be good, right? As simple as that. To the machine learning scheduler, what you feed is channel quality and queue lengths of each user. Let us say in the system there are 100 users in each base station. Let us say base station ID and number of users in that base station and their respective channel quality and their queue lengths and quality of service type, what application they are using, and so on. If you feed it, and we will ask machine learning scheduler to shortlist users dynamically in every time slot, right? And if you follow that approach, we observe that there is a huge throughput gains. But so far, in most of the products, we are following traditional legacy scheduler. But recently, we kind of integrating these solutions, and people are exploring these solutions. Okay, so hope you understood this. So people who doesn't have machine learning background, I will explain you in a simple way. So there is a black box, or like let us say there is a small baby. Okay, if you show the dog and tell him that okay, this is a dog and this is a cat, and next day you might encounter different dog with a different color pattern and so on and different sizes. And if you keep telling a small baby that this is a dog, this is a brown dog, this is a red dog, whatever colors you have, all those, like if you keep explaining or try to tell him that this is a dog and this is a cat and so on, after a couple of days what happens is that let us say you have shown n number of colors. If the new color pattern dog or cat comes, he baby will identify, right? So please say yes or no. I mean, it is quite boring. I say you people should be little, yeah. Please feel free to share. I mean, so
Sir,
let's make it
I
as
have
more
a doubt.
interactive. Yeah. Please ask.
Sir, if it is like scheduler, is it related to operating system, sir? Are we using any operating system principles within this machine learning
Yeah.
here?
So yes, right. As I mentioned in the starting of the TED talk, that the scheduler is important concept for CS people, where there will be n number of tasks and how to allocate the resources, right? computing resources, how you allocate, and this problem, frequency resource allocation for a base station are very similar. Okay, there is a analogy. Okay, they are quite similar. I say the parameters are quite different, but it is more or less same. Yes.
And
Okay.
can we use
So
any other machine learning algorithms along with this, sir? Or is it only through scheduler this implementation can be done?
so basically, yeah, there are a number of opportunities or like possibilities. So this is just one possibility. That's it. Yeah. So you can collect higher layers or lower layers, other module information also to allocate the resource allocation. Okay. Yeah. So
Thank you, sir.
yeah, yeah. As some of you are not having, machine learning background, I'm trying to explain that if you try to explain the baby that, couple of days you say that, show the dog of different pattern and say that this is dog. So what baby picks up is pattern. So what is a dog shape, usual dog shape and facial expressions and similarly cat facial expressions, right? Based on this basically facial expressions and body structure, baby will identify that okay, this is a dog and this is a dog after training means we are trying to explain him that this is a cat and dog and so on by showing different cats and dogs, right? So similarly in the machine learning, uh, so we can consider it as a black box. You try to give couple of inputs, okay, and you output will be some prediction. Basically, while explaining to a baby, you will say that if it is four-legged and if the face is like this is cat. If it is four-legged, this is with this facial expression, probably it is a dog, and so on, right? In the same way, in the machine learning scheduler, how it works is there is a reward mechanism and penalty mechanism. If you guess it correct, and you will be given reward. If you guess it wrong, then you will be penalized. So it will keep correcting itself. Okay. So basically, you can come up with a very good metric by giving reward. For example, if the throughput is good, let us say if throughput is better than legacy systems, legacy means existing systems, right? You can reward that machine learning module. In case if the throughput is lesser than existing system, you can penalize it. What it does is if you penalize it, it will not explore in that direction. If you reward it, it will explore in that direction. I'm trying to explain in an intuitive way. Okay, hope you understood machine learning at a high level. Have you guys got at least little bit?
Yes, definitely, sir. We got it.
Okay, so like I can explain you like how we can do using machine learning. For example, you might have encountered complex formulas, right? Those complex formulas can be approximated using MATLAB software. You might have heard of MATLAB software, right? Have you heard of it? So there are some approximations: linear approximation, nonlinear approximation, polynomial approximations. Y is equal to mx plus c is a linear approximation. If it is polynomial approximation, y is equal to a naught plus a1x, a2x square, a3x cube, and so on. So there are n number of curve fitting formulas. You might have heard of these kind of approximations, right? And there is a subject in engineering in my days. In the first year, there is a numerical computing or numerical analysis, right? Where you might have learned a number of algorithms and so on, right? So you can approximate a function, right? For example, any function can be approximated. So what we do is you will ignore a couple of terms and we'll try to cancel out some terms and try to approximate, right, that's how we do, right? So right now using machine learning you can approximate. Okay, dense neural network, there's a neural network called dense neural network. You generally what you do is you just take some formula. Let us say y is equal to some x cube plus 2x square plus 5x plus something, some term is there. Let us say, or some complex formula. Let us say with some 10 variables, okay, different variables, x, y, z, and so on. In that complex formula, let us say, you can generate random points. Let us say there is a function f of x comma y comma z, and you generate, you know, the range of x, range of y, and range of z, that you randomly generate x, y, z value and compute the value of that function, and you try to feed this to neural network, and neural networks can come up with a approximate formula. This is just one explanation. Okay, I'm just trying to explain. Okay, so there is another machine learning module called CNN, convolution neural network. Okay, so for you might have seen couple of mobile apps where you can edit your photos or you can smoothen your pictures. For example, you can remove background and so on, or maybe you can, you know, beautify yourself, do your photos and so on, right? So all those things can be done using convolution neural networks. There are so many codes in the GitHub where if you are interested, you can go and actually, you know, download those codes and try to play around with it. Okay. Similarly, there is a LSTM. So this LSTM is a module where, for example, if you try to see the temperature of Hyderabad from 9 a.m. to 9 p.m. and if you feed the data for a couple of days, and if you ask a temperature how pattern, for example, if you feed the temperature pattern at 9 a.m. and it will predict what is the temperature at 10 o'clock based on the last 2 months or 3 months data. Okay, so if there is a time series data, if it can be anything, for example, traffic patterns, you know, or user distribution in the base station, or the temperature, whatever you want to predict. Example, if it is a time series, you can use LSTM. Okay, you can use LSTM model to predict it. So these are the some of the machine learning modules. What I'm trying to say is that you can use machine learning for almost every subject and any subject, not only to non-engineering, especially drugs where, like, you know, you can try to predict the structure of a molecule and try to, you know, utilize the properties and try to find a medicine and so on. Okay, so right now CS people can use machine learning for their speech processing and image processing and video editing and compression techniques. You know, so far we are doing some compression techniques, right? You might have heard of a basic Hamming code or Hanning code and so on, right? Or differential coding, right? Have you heard differential coding, Hamming, Hanning, right?
Hamming,
So
Hanning.
yeah, so these are the techniques used by computer science faculty as well as EC faculty to compress the data. Now, you know, so there are n number of machine learning compression algorithms have come. Okay, if you are interested, you can always go through that. You know, so many codes are there in the GitHub. You can explore in your free time and try to explain it to your colleagues and so on. And each faculty can come up with that kind of, you know, learning and presentation. If those things might help you guys. Yeah. Going to the next slide. So far I'm assuming that you got some basic idea of machine learning and why it is so important for you, right? Yeah. Sorry. So I got a call. So these machine learning algorithms, so far what is happening is in the 4G systems and 3G and 2G systems, so most of the computation is done in the hardware. Now we move towards the cloud. Okay. So advantage of the cloud is that, let us say in the morning time your college base station is heavily loaded. In the evening time, most of the faculty students might have left, right? And the base station will be lightly loaded, right? Suddenly 3,000 students became hardly some 300 students, let us say, assuming that 300 students are there. So, so what happens is that base station you have to keep I mean, base station consumes a lot of power. You have to turn on, right? So right now what they do is they placed a small antennas. Right now they are placing only small antennas called RF antennas, and rest of the computing, all the computing is done in the cloud systems. Okay, so what is the advantage of computing in the cloud system? Advantage is that, so example, if there are 10 base stations, let us say take a city of Hyderabad, let us say population is 1 crore. At the end of the day, or in the morning or afternoon, the number of people in Hyderabad will be 1 crore plus or minus 5 lakhs, right? Let us say, right? If you do all the processing of all the layers, information of every user in the cloud, it is optimal, right? It is like a cloud kitchen. So cloud kitchen, advantage of cloud kitchen is like this. For example, if there are 10 colleges under your main branch, let us say, you want to serve the food for all the branches, instead of cooking in every branch, so if you cook at one main branch and serve that food everywhere, that will be optimal in terms of money and so on, right? Right? So in the same way, uh, you know, we can do all the computing which we have done in the hardware, we can also do it in the software, and this software we can keep it in the cloud. We can do all the processing of all the users of whole Hyderabad in one cloud. Let us say, so this will be much cheaper and faster. Instead of that, if you keep a server or big base station at every location, operator have to spend a lot of money, has to pay some 10,000 or 5,000 rupees for each base station at every location. You should have UPS system in each location and so on, right? There are a lot of things which operator should take care, right? So real estate space is quite expensive. What they do is they will take all this computing part to, in some cloud region. This cloud region where there will be multiple servers and so on, that will be outskirts of the Hyderabad. Rental will be less usually, right? So right now we are moving towards a cloud-based system. So far we are hardware centric systems. Now we are moving towards a cloud. In the cloud, people have come up with novel architectures where you can actually run machine learning modules irrespective of the layers. You might have heard of 7-layer architecture in the computer networks. You might have heard of it, right? Similarly, there is a 7-layer architecture in the telecom domain also. So, and most of the layers, almost all layers, you can move it to the cloud. By doing this, you can actually reduce your expenses. And at the same time, you can also do this. You can optimize or you can do machine learning right now. So that's the reason, as we are moving towards the cloud, machine learning framework is there already right now since couple of years, almost 3-4 years. Now you should explore the machine learning and you can do many things. You have a lot of data. If you have a lot of data, you can actually run many algorithms and take some inferences. For example, Samskruti College, how many students are there at 9 a.m., 11 a.m., 10 a.m. I will get to know. Based on that, I can turn off couple of antennas. Okay, you might have heard of spectrum auction, right? Each operator will have multiple spectrums, multiple frequency bands in simple language, right? If the load of the base station is less, what operator can do is he can turn off couple of antennas, right? So these kind of optimizations are all possible if you have data patterns and if you have some control, software control. I mean, you cannot keep one person to take care of base station near Samskruti College, right? So it is quite expensive for the operator. So if you move towards the cloud, your life will be easy, right? Yeah. So far I am assuming that you got something out of machine learning. Why you need machine learning for telecom domain or computer science domain or processing domain? Yeah, you got it right.
Sir, I have a
Yeah.
doubt. In this,
Yeah.
when will we go for this linear analysis and when we will go for
Linear
non-linear
analysis.
analysis?
You mean to say that when you do approximations and when you do non-linear approximations?
Sir, actually, it is. I just want to know about the algorithms. Generally, we go for linear and logistic algorithms, right? So if the
Yeah.
data is discrete or continuous, so here based on this communication technology, like how will you segregate the data,
Yeah.
sir?
Madam, so far till 4G systems, even 5G systems, we are actually going with linear models. Okay, with linear models, our life will be very simple. In terms of hardware, hardware will be actually cheap. If it is non-linear, then hardware will be quite costly. Okay, but right now we are moving towards a machine learning models. So machine learning, in every machine learning module, there will be some non-linear functions. So right now, due to NVIDIA and other chipset vendors, so we are able to compute non-linear functions quickly. For example, as you are from engineering background, you see, for example, time taken for addition, subtraction will be same. For multiplication and division, it will be more, right? Number of flops will be more. Similarly, to find the square root of a some function, you need to spend more number of resources, right? See, you know, as the function complexity become more complex and complex, number of flops will be more. So to make our life easy, all these people, what they have done is in the telecom domain, all the analysis, more or less, most of the analysis is done assuming or approximating as a linear function. Okay?
Okay,
So,
sir. Thank you,
of
sir.
course, there will be some nonlinear function keep coming in terms of phase, in terms of interference, and so on. But we have to live with it, and there are some couple of redundant bits, and based on that, we will try to decode the data. Okay? So, as you asked this question, also this is quite important to the communication systems and computer science people, where you might have heard of coding, right? Like if you want to transmit 10 bits, you will add some 4 or 5 bits, and you will transmit it, right? Right? Why you want to add some 4 or 5 bits? Just because in case if the bits gets corrupted due to noise or interference or any reason, the receiver should be able to decode it. In case if it is not decoded, you will get the NAC, negative acknowledgement. In that case, again transmitter will transmit same data or some other data, such that if you combine these two packets data, you will be able to decode it. Okay? So you will use all these techniques like coding techniques in the telecom domain. Of course, in other domains also you will use coding techniques, right? So right now machine learning has come, and it can also recognize the patterns. As I mentioned in the earlier example, cat and dog example, for your understanding, right now we can actually use machine learning to decode faster, to reduce the interference, to predict the interference, right? And so on. Many things are there which you can do using machine learning in CS domain as well as EC domain. Okay? Yeah. So right now we have observed using machine learning scheduler, we have observed that we have gains of solid 30% gains when compared to the traditional round robin and PF scheduler, proportional fairness scheduler. Okay. Let's go to next slide. Yeah, tell me. You have some question, right? Please ask me. Yeah. So single radio access technology. Okay, uh, single radio. So as I mentioned earlier, there is single radio access technology and multi radio access technology. In this single radio access technology, there are different types of cells. Okay, so for example, a base station which is in the village covers 20 kilometers radius, and the base station which is in the city covers hardly half kilometer or 1 kilometer. This is due to the density of population in villages. If you cover 20 kilometers, hardly you will have 5,000 or 10,000 people, right? In the cities, you will have the same density within half kilometer or 1 kilometer radius, right? So in the cities, usually we will have one base station, which is macro, and remaining base stations will be like femto and pico base stations. The coverage area of the pico and femto will be smaller. Okay. So these base stations can operate on the same frequency bands or different frequency bands, and there will be some coordination in the back end, how these base stations operates and so on. Okay. So if it is like for example Reliance and Airtel, what they do is they use same frequency. Okay, why they use same frequency? To meet the throughput requirements of the user. If you go to Europe and other countries, what they do is usually they use different frequencies for different base stations, and the same pattern repeats. For example, if you use frequency, let us say in location X some frequency F1, and the next frequency nearby area they will use F2, and after F2 they might use F3, and then after F3 again F1 will start, again F2, F3, and so on, so that if you keep the distances, interference will come down. For example, if I am talking here in a conference room, let us say, there will be small interference to the people who are sitting next to this conference room, right? But if you leave that room and if you go to other room, interference will be negligible, right? Right? So if you maintain the distance, noise or interference will keep coming down. Okay, so what operator does is the main base station, which is at the center, you call it as macro base station, it will control all the pico base stations, nano base stations. Okay, the coverage area of the pico and nano base stations are very small. Okay, so if you are in particular location, if you comes under picocell, it is fine. If not, it will allocate the resources in such a way that whichever base station is best for you, it will allocate it. For example, you might be in a situation where your center of all the 3 base stations are 4 base stations. Then base stations, what they will ask user equipment is, okay, can you please tell which is the best base station for you in terms of signal quality? It will listen from all the base stations reference signals. As I told you, there is a reference signal. Base station will shout or send reference signals periodically, and user equipment means mobile device will listen from each base station periodically, and it will check which is the best base station for that UV, and it reports back to the main base station, and main base station will convey the same to other base stations, small base stations, and it will latch on to the appropriate base station. Of course, there are some factors such as load and so on. If the load is heavy on the best base station for that UV, it will ask to latch on to next best base station. Okay, so there are some challenges how to allocate frequency resources, or like how to maintain, or how to reduce the interference and so on. These are kind of both computer science problems as well as EC problems, right? As I mentioned, if there are 200 users in a given base station, how to shortlist 20 users or 30 users is itself one challenge, right? So this is a problem for computer science as well as EC people. Okay, so basically, as I mentioned, this is single rat architecture, and let's go to next slide. So basically same operating frequencies are used in macro and femtocells in the head net if it is a single rat. If it is a multi-rat, you can allocate different frequencies. For example, picocell will have some frequency, femtocells may have different frequency, and macro base station will have different frequency. But so for developing countries, they want to actually provide this service for cheaper prices. So what they do is they will use same frequency. What is the penalty for using same frequency? There will be interference, right? For example, in the given room, if 2 people are discussing something, the interference is 0. Again, 2 more people joins them, and if those 2 people are discussing in different language or same language, let us say, there will be some interference, right? The first pair will experience interference due to pair 2, and pair 2 will also experience interference due to pair 1, right? So in the real world, in the base station scenario, is what I am trying to say here. So there will be users which will be communicating with the macro base station. Some users might be communicating with the pico base station. So it's like communicating is nothing but they will be shouting in a radio waves, right? So Pico base station will shout to its users, and users in that Pico base station will shout back to base station, right? In the uplink and downlink, right? So there will be some interference. Neighboring base stations will listen some noise or interference. Similarly, users also will have some interference. Okay, due to other base stations as well as other user equipment. Okay, these are the challenges, but operators actually prefer this kind of resource allocation in developing world. Okay, as we can provide for cheaper service, right? Okay, next slide. Here, HETnet means heterogeneous networks, where we will have different base stations and their capabilities are different, and coverage areas are different, base station powers are different, and so on. And there are some challenges here, like what kind of transmit power we have to choose. For example, if you shout, probably everyone can listen your lecture. If you speak little with low voice, then what happens is that probably first 2-3 benches people will be able to get your lecture, right? So similarly, macro base station should figure it out what is the optimal power for neighboring base stations and so on. So there are some challenges here anyway. Those are all non-linear problems. Have you got a chance to, I mean, teach or learn optimization theory? So this is one of the course which is very important for people who are interested in working in machine learning. Okay, there is a linear programming and there is a convex optimization, which and non-convex optimization is also there, where you approximate the functions and try to solve those problems and try to come up with near optimal solutions. Okay, computer science people might have heard of it, linear programming. I'm not sure whether EC people have encountered or not, but it is a master's related course. Yeah, have you heard of it? Optimization theory, linear programming, and so on. Okay, so there are some advantages, okay, with a single RAT and so on. So you will have higher throughput, but at the cost of what? You need to come up with a good receiver where it can distinguish signal and interference. If you can remove the interference as much as possible, you can decode the signal faster. Otherwise, you have base station or transmitter will retransmit multiple times, so that receiver will decode the data. Okay? Yeah, coming to the next slide. So multi-rat HETnet scenario. Here, as you know that users usually use Wi-Fi. There are different types of Wi-Fi's anyway. Multiple Wi-Fi bands are there, and they have multiple versions. So the spectrum which we use in the home is for free, right? We are not paying any money to government, right? Right, you are just paying money for the service provider who is providing the internet, and this Wi-Fi router will blast some RF power, and that's how your mobile will catch some signals and receive the data, and vice versa. You will also transmit the data, and your Wi-Fi device will listen using its antennas, and it will decode and it will send it to nearest base station and nearest core circuit, and that is how it will be routed. Okay, so right now operators also can use Wi-Fi spectrum. Okay, it is free. See, we are using for free, right, without paying any money for the spectrum which we are using. Similarly, operators can also use Wi-Fi band for free. Of course, there are some challenges. If you are using your Wi-Fi at your home, and if operator also uses a same frequency, then there will be interference for you as well as for him. Let us say you are using Wi-Fi at your home, and if your neighbor doesn't have Wi-Fi, and an operator like Jio or like ATAL is using Wi-Fi band to transmit the data to your neighbor who is sitting in the first floor or ground floor, he will also receive the data. But problem is, he will actually experience interference from you, from your home, as you are using Wi-Fi band, and also operator, right? So, but what is the advantage of using Wi-Fi band for the operator? It is free band for him also. It's free. So operators can use it, but this is not so reliable. Okay, the band is not so reliable because you don't know how many people are using Wi-Fi, where they're sitting. That information is not available. Okay, there are some tens or twenties, service provider, Wi-Fi service providers, right? And if you people are also using Wi-Fi, and if operator also uses, there will be a lot of interference, right? It is like this: in the same rooms, there are 10 pair of people who are discussing, and everyone will experience interference from nine pairs, right? So same way, it is not so actually good in terms of what throughput will be low. Okay, but it is a free spectrum for operator. He will get extra capacity and extra coverage and so on, right? Yeah, at least some users, mobile users, might get benefited. Yeah, this is multi-rat, heterogeneous network. Rat means here Wi-Fi bands are also used. 4G bands, 4G bands are nothing but LTE. Okay, so there are multiple radio access technologies. So we call multi-rat. Okay, yeah, rat means radio access technology. Yeah, let's go to next slide. Any questions so far? Feel free to ask me any question.
Can you please tell a overall methodology? Like suppose if you take an example as like to separate the signal and interference. And the next part, through machine learning algorithm, I'm just finding whether it is a signal or interference. After that, the procedures, like overall methodology, can you please tell us, sir? Along with the metrics.
See, so it's a, actually you asked a very big question. So, I mean, explaining it in a minute is quite tough, I say, but I can discuss this in offline or like over the call or mail and so on. So is it okay? So I have to cover another 20 slides.
Yeah, I
Madam?
understand, sir.
Yeah.
Thank you, sir.
But this can be done. Okay. Yeah,
Okay,
this
sir.
can be
Thank you,
done.
sir.
I will explain little later. Sorry.
Thank you, sir. Thank you, sir.
Yeah, let's go to next slide. Already I covered benefits at high level. Let's go. Yeah, so when the operator is using Wi-Fi, there will be a lot of interference, and then you have to come up with sophisticated algorithms and complex receivers and so on. Okay, these are the disadvantages. Let's go to next slide. So far you have, I try to explain you so far what is MAC scheduler and why you need scheduler and why base station should be fair to everyone while allocating the resources. And there are two types of channels: control channel, where that channel is used between transmitter and receiver to discuss the channel quality and Q lens and other parameters, decoding parameters. But there is another channel along with the control channel. There is called shared channel, where your real data will be exchanged. When the real data is exchanged over a shared channel, you need to decode the data, right? All those data will be decoded using control channel data. Okay, so for example, so there is a data chunk which I transmit to you, let us say, right? To decode that, you need some cheat sheet, right? Like how to decode. Okay, based on that only you will be able to decode, right? Right, that's how data is transmitted, kind of encrypted in simple language. What encryption code you used, okay, what method you used, how to decode, those parameters also will be shared in the control. In the control channel, you will use a dump scheduler like round robin. In the shared channel, where you will send real data with encryption, you actually use shared channel there. We use proportional fairness scheduler, and some people started implementing machine learning scheduler also. Okay, so and there is a single rat scenario and multi-rat radio access technology, and there are a couple of advantages and disadvantages for both single and multi-rat technology. So for everything, as I mentioned, channel quality is quite important. For example, as you people are from teaching community, So time taken to teach, let us say some chapter, let us say some chapter X, you want to teach to a smart kid. Let us say you spend 2 hours to teach, right? So for example, if a student is dumb, you might need 4 or 5 hours, right? To make him understand, let us say, right? In the same way, you should means here in the coming to the telecom domain, we should know the channel quality. Based on that, we will select the appropriate MCS. MCS means how many bits you can pack in a given resource. If the channel is bad, we will pack less number of bits. If the channel is good, we will pack more number of bits. Okay. So this is at high level for both computer science and EC faculty. If for EC faculty, there are modulation techniques. Okay. So QPSK and BPSK, QPSK, 16 PSK and so on. Right. Based on, like, if the channel is good, you will go to higher modulations. If the channel is bad, you will stick to QPSK by BPSK. So let's go to the next part of the presentation, where we will estimate the channel quality basically using machine learning, and also I will also explain you how it is done in the existing systems. Yeah, right. One more concept which I thought of sharing is that Samsung is working on this technology where 4G frequency bands are used by 5G base stations, and 5G frequencies are also used by 4G base stations, and they will intelligently communicate to figure it out what spectrum will be used by which base station. Okay, this is something which is new product. Okay, go to next slide. So I will try to ask some questions. I mean, this is so it's not so interactive. I like to have that interactive sessions. Okay. So for example, if I okay, go to next slide. As you got the flavor of machine learning, can I ask you some questions? Feel free to answer me. If you, it doesn't matter whether you tell the right answer or wrong answer. So for example, if I tell you the temperature at Birla Mandir and Charminar, and if I ask you to predict the temperature at a given point of time in the Secunderabad railway station, let us say, will you be able to guess it?
We can.
Approximately, we can, I guess, sir.
Yeah. So usually you are guessing based on your knowledge, right? Right. Let us say someone is staying in the Secunderabad railway station area, and you people are, actually, let us say your college is near Birla Mandir or Charminar and so on, right? So using machine learning, you can do this. For example, I mean, you may be right with 95% probability. You may not be right all the time, all the days, right? It can so happen that when you are at Birla Mandir, it might rain in the Secunderabad. It might rain, right? So whenever it rains in the Birla Mandir area, probably it will also rain at the Secunderabad area, right? Let us say every day, if I ask you what is the temperature, or what is the climate condition of Secunderabad railway station, just by giving the information details of Birla Mandir and Charna, let us say. So you will try to guess, right, based on the past data, Excel data. Let us say I will give the data of last 2 years, right? If I give data for last 2 years, what you will do, I mean, if you are from computer science or EC, what you will do, you will try to come up with some curve fitting formulas, right? Right. And with high probability, you might guess it. I mean, most probably you will guess it and so on, but not 100%, right? Right. So please answer. Huh? So, are you getting what I'm trying to say?
Yes, sir.
Okay. So similarly, so we came up with this patenting idea. Okay. Channel quality estimation using machine learning. Okay. You can see that there are so many frequency bands, right? You can see that what is the bandwidth in each region available for telecom domain, right? There's so much of bandwidth. But if you want to estimate the channel quality across, it is quite time consuming, right? Time consuming, and also your battery will be drained just because you are trying to listen to the base station reference signals and trying to decode those signals and so on, right? Right. So right now, as you people are guessing, Secunderabad railway station temperature based on the remaining two location temperature, what we proposed is we can estimate the channel quality on other bands, frequency bands, by estimating on couple of frequency bands. Let us say there are 100 bands. Let us say, for example, if you estimate channel quality on 10 frequency bands, remaining 90 bands you can guess it approximately. Okay, right? Like let us say if I share the climate conditions in 10 locations, let us say like I divide Hyderabad into 10 parts, and let us say for every region, let us say I will find some center point and I will tell the information, okay, what is the temperature on a given day across these 10 locations. If I ask you in the neighboring regions, let us say what will be the temperature, you can guess it, right? You can divide whole Hyderabad into 100 chunks, and based on these 10 locations you can guess in remaining 90 locations, isn't it? With high probability, with good probability, with good guess, you can do it, right? Right? Yeah. In the same way, you can also estimate the channel quality of other frequency bands by computing couple of frequency bands. Okay, this is the intuition. To solve some problems, we need to have some intuition which will help you, to solve some tricky problems. Mathematically, you can't derive the formula. It is quite hard, I say. Right? But what you can do is, you can use machine learning for such a problems to estimate it. Okay? Hope you got it. Any queries so far? Any questions? So no questions. So I'm assuming that you are not wasting time here, or I'm assuming for now that you are all getting whatever I am explaining. Okay. So I hope that your time is not getting wasted. Okay. But I'm trying to explain in a very simple way. I don't know your backgrounds and so on. Yeah. Yeah. So let's go to next slide. So, see, you can see that whole spectrum is divided into multiple frequency
Sir, I
bands.
have one question, sir.
Yeah, please go ahead.
Sir, how do machine learning enhance the AI, sir?
Sir, how do?
How do machine learning enhance the AI technology, sir?
I didn't get. How do machine learning and AI related? You mean to say?
Yes, sir. Yes, sir.
See, machine learning has couple of algorithms, and if A is considered as a big circle, and a smaller circle inside that bigger circle is machine learning. So one should start with machine learning algorithms. Once people are comfortable with machine learning algorithms, they can actually learn couple of more algorithms so that they can cover artificial intelligence. Okay.
Thank you, sir. Thank you, sir.
In simple language, I'm trying to explain. Let us say in machine learning, DNN, dense neural network, and convolution neural network, and RNN, LSTM, you can call it with both names. These usually classification, right? If you want to classify certain area and so on, you want to partition on some basis, then all these algorithms are all usually machine learning. Okay, if you go to next level where you will use um, reinforcement learning, supervised and non-supervised at high advanced algorithms, then you, in simple language, I'm trying to explain, it's quite hard, I mean, to explain everything in a minute, but if you go to advanced level where supervised and non-supervised learning and all those things will come under AI. Okay. Yeah. Yeah, and data science will be subset of machine learning. Okay, yeah. Okay, so go to next slide. So I will ask some questions like for fun. let us say if I give the average weight of the class or average height of the class, and if I give average, let us assume for time being, for simple case, I will just give a simple puzzle. Like students usually sit in, let us say not in engineering, in the school days at least, where students usually sit based on their height, so that everyone can see the board, right? That's how it happens in the school days, right? If I give average height of the class and first bench and third bench height, will you be able to predict second bench height? All right, one simple method is you can do simple average, which is a very basic math which you might have learnt in the school days. But so that is a simple approximation answer. But you can use machine learning to predict accurately. Okay, second bench people height based on third bench, first bench, and average height of the class. You can also predict fourth and fifth bench and sixth bench, and so on. Of course, this accuracy is a function of the information which you are feeding, right? For example, if I just say that Birla Mandir temperature or like whatever climate conditions, if I feed it and if I ask you to predict it Secunderabad climate, you can predict it with some error, right? If I give like Birla Mandir temperature, Charnar, something, some other nice road or whatever, let us say if you give like some 10 location information, if I ask you one location, then the accuracy of your guess will be better, right? Same way, these machine learning algorithms will work better, accuracy will be better if you feed more information. Okay? Got it? So right now we will be estimating channel estimation, channel quality estimation, right? In the telecom domain. Coming back to this problem, so if I estimate channel quality on couple of frequency bands, and if I ask you to guess it on remaining bands, okay, you will get certain frequency, certain error. You will guess it, but with certain error. If I just feed one channel quality information, only one band, if I ask you to guess remaining 99 bands, let us say, you will find it hard, right? But accuracy may be, not so good. If I feed some 10 frequency bands and if I ask you to guess 90 frequency bands, then accuracy will be slightly better. If I ask you to guess remaining 60 bands by feeding 40 frequency bands, then accuracy will be better. If you understood, right? The more the information which you give to machine learning, the better the quality of the guess. Okay? You got it so far? So,
Sir, I had a doubt.
yes, madam, go ahead.
What are the features you will consider for estimating the quality of the channel?
So features means what we do, madam.
Input
So we will,
features.
yeah, madam.
For a machine
So,
learning algorithm, we will give some input features, and the output is but quality of the channel.
yeah. So
What
you are,
features you will be considering in order to determine the quality?
so channel call. Okay, madam. Let's go to next slide. It is covered in the next slides. So is it okay if I take another 10-15 minutes extra? You might be having so many commitments, right? Next slide. Next slide. Next slide. Next slide. Yeah. So, madam, so this is the method, madam, which we use, but there are like a number of variants. Academia people will use some formulas. Industry people might tweak this formula here and there, and then they will compute and so on. Okay. All these formulas also, to some extent, they have their internal patents. Okay. So they compute H matrix, which is called channel matrix. Okay, how they compute channel H matrix is also a different algorithm altogether. As you know the reference signal, so what base station is sending, you know it, and what you received also you know it, and you have to compute H. So it is like that. Y is
First,
equal
we
to,
have to do channel estimation. Later, we have to go for quality of the channel
yes, madam.
determination.
Yeah. If
So
noise
this
is,
is just a formula to calculate the quality of the channel.
yes,
But actually, we are doing estimation of the channel.
yes, madam. Yes. There are some methods to estimate it, right? H values.
Yes.
Once you estimate it, see, channel is assumed to be linear. Though it is not linear, for our mathematical convenience, y is equal to hs plus n. Let us say n is approximately 0. Y is the actually received signal, x is the transmitted signal, x is known to the receiver, and you have to compute h. So y divided by x is equal to h. Once you know the h, you compute the SNR. From the SNR, you will compute the CQI. There are some lookup tables based on the SNR. Every company has their own kind of mapping. If the range is in 1 point, some like A to B, then this is the channel quality. If it is B to C, this is the channel quality, and so on. So all those tables are like, kind of secret to the company.
Okay.
Yeah.
Sir, it is a supervised learning, or we have to go for a reinforcement learning for this?
Madam, so all the architectures are quite possible. So we have explored simple neural network, dense neural networks. I will go through that. So can you please scroll down? Yeah, so this is the architecture which I was telling you. Couple of bands, channel quality is known. For computer science people, as they doesn't know what is CQI and so on, couple of areas, temperatures are fed to the neural network, and the output is that other areas in the Hyderabad temperatures can be estimated for computer science. For ECE people, estimated CQI with bands of unknown or unmeasured areas. So these can be estimated by the UV, or base station can estimate it itself. Base station has a lot of computing power. The base station will simply ask to estimate couple of CQI subbands, and based on that it will interpolate. Okay, yeah, let's go to next slide. We have proposed, so as I said, there are multiple frequency bands. Every operator will have usually multiple bands, and you can measure in one band and you can estimate in other band. You may not write all these problems mathematically because there are n number of parameters which comes into picture. It is very hard to formulate it, but you can estimate using machine learning. Okay, earlier we used to measure it. Now we are using the AI framework at the UV side or base station side and so on. Go to next slide. Yeah, so yes, trying to explain in animation way, nothing more. Next slide. Yeah, so I'm trying to explain you the machine learning model which we have chosen, how many layers, so how many nodes. So all the circles are called nodes, and if you see that each straight line, vertical straight line, that is called layer. So here we have input layer, output layer. If you exclude input and output layer, we have 4 layers. So this is one architecture, and the architecture details are explained in the table. And yeah, just to get a flavor, like there is another architecture. Let's go to next slide. Next slide. So this architecture is much bigger. You can see that there is an input layer and there is output layer, and there are multiple nodes, 64, 512, 1024, and there will be a number of connections, very hard to draw, and so on, right? If you add more number of layers, computation complexity will increase and the prediction will be better. Okay, so at a high level I'm trying to give you intuition of various architectures, and there will be some activation function concept which you might have heard of it, and those n number of activation functions, close to 10 activation functions are there. Based on the activation function, the output quality will be a kind of, you will get different outputs. Different activation functions will give different outputs usually at high level. Yeah, go to next slide, please. Yeah, I'm just trying to give the parameter details of this machine learning model. You don't need that, but if you get the intuition of all the presentation, that is good enough. Yeah, so go ahead, next slide. Of course, while doing training the machine learning model, you need to have enough data, clean data. In case if some data is missing, so you have to interpolate it and make the data clean and train it. And while testing, you should not pick the same data. It is like this. Usually in the classes, whatever they teach, if you ask same questions in the exam, people will get better marks, right? If you ask some questions, if you explain something, and if you ask some tricky questions in the exam, then people may get less marks, as simple as that. Similarly, in the machine learning, when you are actually implementing, training data and testing data should be independent. It should not overlap. That we should take care. Usually beginners will do these kind of mistakes, and if you mix it up, then people get very good results and they will be very happy, but in the real world it will not work. Okay. Yeah. So this is like, if you feed more information, like, so in this slide I have explained it to you. I am trying to feed 3 sample inputs and trying to predict 8, and later on 4 samples, 5 samples. If I keep increasing the number of samples which I am giving, more information if I am giving to a neural network, the accuracy is going up. If you see that in the first case it is hardly 70%. When I fed some 3 samples, accuracy is 70. If I fed for 7 sample input and asking it to predict remaining 7, the accuracy is close to 80%. So as I mentioned intuitively, that the more the information you feed, the better the accuracy it is. Yeah, go to next slide. I try to compare both architectures. You can see that, sometimes if you add more number of layers, it may not result in better quality, right? So it may become saturation. Okay, sometimes it can so happen that you add even, like, n number of layers, 100 layers, 200 layers, performance may not improve. Okay, so these are all concepts which you might encounter when you try to implement all these ML algorithms in your projects. Okay. Yeah, so these are like, MSE, minimum mean square error, to check the performance, and so on. Yeah, go to next slide. So why we are doing all these estimations? So it will improve the battery efficiency of the mobile device, right? Also we can save spectrum, right? So if you ask UV to measure all these measurements, UV battery will actually die, right? You might have observed that while traveling your battery will drain faster, though your usage is very less. This is because you will be keep latching on to new base station after new base station and keep testing and checking the channel quality and so on. So you might have observed while traveling there, while traveling, right, in the train and so on, right? Though your usage is negligible, but battery consumption will be more, because so when user is moving from one base station to another base station area, there will be handover. So this base station will ask other base station to, take over this UV and so on, and there will be some measurements which UV has to do. So by doing all the measurements, battery will die, and this is not so efficient approach. So to reduce the battery usage and also to improve the spectrum, we can use machine learning to predict it and so on. Okay, there are n number of applications. There are thousands of papers and patents on these works. Okay, yeah. So hope you understood something out of this presentation. If you get it high level, that is more than enough. I will be very happy. Yeah, any questions? Please let me know. So I will share my mail ID or LinkedIn. You can search for Satya, SATYAKUM.
Sir, I'm Karthik.
Yeah, yeah.
Sir, is machine learning is will effective for the spectrum sensing in cognitive radios, sir?
Yes. Hundreds of papers are there on that. Yeah. Yes.
So
Okay, sir.
can you list out the areas in which this communication and ML can be?
Madam, there is no layer which we can say that we can't use machine learning. You can use it in physical layer, you can use it in MAC layer, you can use it in RLC layer, you can use in a PDCP. We are using in the cloud, right? See which base station to turn off at night time. Some base stations will turn off at night time based on the load and usage, right? See, I mean, at least for me, almost 99% or 95% areas you can actually use machine learning. We can revisit those problems and we can apply, and probably, you can Google it out, or, in IEEE, I don't know whether you have access to IEEE or not, but there are good number of papers on almost every topic now. Yeah, go ahead. Next question. Yeah, we are also working on beamforming using machine learning with IIT Patna. There is a MOU which is going on. So we are using, yes. We can also predict, for example, if you're like after your college, what usually faculty do at 4 o'clock or 5 o'clock is they have to go to their homes, usually with high probability. Out of 5 days, at least 4 days, they will go to home directly, right? So based on your UE, ID or phone number or EMI number, whatever number at high level I'm trying to explain you, we will actually allocate the resources once you start at your office till you reach your home. We can actually guess your path. We can allocate or reserve the resources for you based on based on your usage pattern and so on. Yeah, next question. Next question, Stalin, you can ask. Yeah, Stalin, you have any questions? Okay, so I think he actually kept it in mute, I guess. Yeah, any other questions?
Any other questions from any other participants?
So someone is asking how it is so energy efficient. It is as simple as that. For example, if I am spending 1 rupee on energy, I should get reward of 1.05 rupees, right? Right? So, yes, there is a penalty in terms of computation, energy, and so on. But the reward is actually more than penalty. Yeah. Any other question? Otherwise, we will not use machine learning. As simple as that. Yeah. Yeah. Any other question? What is the question?
Dear participant, any other question? Please ask. Padma Priya madam, you are asking something.
Can you hear me?
Yeah, yeah. Go ahead, Padma.
Drawback of Adnet. Any unique one?
What is the? Sorry, I didn't get it. So someone can someone explain it to me?
Madam, your voice is not clear, madam.
Okay. Any other?
Chat box.
Yeah. Any other question? Yeah. Feel free to ask me. You can connect me over the LinkedIn or over the mail. You can drop your queries. I will try to address as soon as possible. I will be having my own office works. If you, I mean, sometimes I might delay it, but you can keep reminding me.
Sir, if we want to do research on this, where can we get the data sets?
Madam, you can find data sets in GitHub and MATLAB. So MathWorks is a company where they have a lot of data sets and they have a lot of tools. You can reach out to MathWorks Hyderabad.
Okay.
Yeah, GitHub is a good place to explore. I mean, it will expedite your research activities. There are a lot of data sets and a lot of codes. On top of it, you have to play around and you can actually come up with a novel architecture and you can show the gains and so on. That way,
So
you can publish some papers.
for this quality of channel prediction, can you tell me any data sets, relevant data sets of GitHub?
Madam, usually we'll find a lot of GitHubs, but we use the Reliance base station, Geo base station data sets. But usually, madam, yeah, GitHub is a place where like you will find a lot of codes and data sets, and there are like a number of softwares which are providing these data sets. So, for example, if you buy those softwares, you can emulate or you kind of you can use this for generating data. Almost it is very close to real-time systems.
In Kaggle, you can get, sir. We can.
So, madam, that I can't answer. I have not used it, but we have access to real-time systems, and and
Okay.
MATLAB and other systems, other softwares. So, but yeah, I think you'll get some accuracy for sure. Yeah, you can actually explore for fun. I mean, without any high expectations. Yeah.
Okay, sir.
Any other questions?
Good evening, sir. Can you hear me?
Yes, madam. Go ahead.
What is the major drawback of HETNet?
See, madam, in the HETNet there is a single rat and multi-rat, as I mentioned, right? So single rat is very smooth, it is easy to implement, but there is a interference issue because even like in simple language there are like micro, macro, pico, all these base stations are there, right? So uh, so what happens is that pico base station will create interference to macro base station and vice versa. So you have to come up with intelligent interference estimation algorithms, and you have to remove the interference as much as possible and try to decode it. That is a disadvantage. Advantage is very smooth. It is very easy to have a handover. All this analysis handover process will be very simple. Okay, that is one thing. But if you go to multi-rat, you will get free spectrum called Wi-Fi spectrum, and operators will try to utilize the Wi-Fi band. But the drawback is that um, you know uh, the quality may not be as good as a single rat and so on. Yeah, but we all have to live with multi-rat or single rat systems. Usually, usually most of the base stations in India are single rat. Yeah. So, for example, Reliance base station, more or less the size of the base station and everything, almost all capabilities are same. Yeah. So, any other questions, madam?
Sir, what is the cause for interference in single rat, sir?
Yeah, in the single rat, there are, as I mentioned, macro and pico base station or nano base station can coexist, right? But they all use same frequency. It is like, there are some 4 or 5 pairs who are going to discuss in the same conference room. So, for each pair, remaining 4 pair discussion is an interference, right? It is like that.
Okay, thank you, sir.
Any other questions? So, any other questions? Feel free to ask me.
For participants, any other question is there? Okay, thank you, respected Dr. Satya Kumar Vankala, sir. Your presentation on resource allocation in heterogeneous network was not only informative but also very engaging. We have gained valuable insight that will surely contribute to our professional growth and understanding of the subject. On the behalf of ECE Department, Sanskriti College of Engineering and Technology, I would like to extend our heartfelt thanks to our speaker, Dr. Satya Kumar Vankala, sir, for sharing knowledge and experience with us. We also appreciate the time and effort you took to prepare today's session, despite of some challenges of that virtual setting. We thank you, sir. Thank you on behalf of our ECE
Yeah,
department.
thanks for your invitation. Hope you people got something out of my talk. In case if you have not got anything, I'm really sorry.
No, sir, we have
So I
gained a
tried
lot.
my
Sir.
best
It was
to
really
make
nice.
everyone get something out of this talk. I know that there are like different faculty from different departments, and it's not so easy to handle everyone.
Yes.
Yeah. So yeah, thanks for your
Uh,
time, and good luck for all future research.
Thank you, sir.
Yeah.
Thank you for your
Yeah.
valuable time.
Yeah. See you.
Mm. Now, for the participants, we will start our second session now. Our first session is concluded.
Anuptivari sir, you were,
Ma'am,
uh,
Ma'am, please send the feedback link again, ma'am.